Assalamu alaikum everyone. I am Navid Afzal. I am the first member of our group who is going to present on our topic, which is design of a prototype generator based on piezoelectric power generation for vibration energy harvesting. I want to sincerely thank at first to our respectable faculty, Dr. Muhammad Alif Arman sir, for giving us a wonderful opportunity to present on our topic. I also want to acknowledge our group members. Among them, the first is MD Abu Rubayat Rokun. The second is MD Imtiaz Hossein Akash. Third is MD Omar Farouk. Fourth is Rafin Kabir. Fifth is Tanzila Zaman. And sixth is me, Navid Afzal. So our whole topic or our whole presentation is scrutinized or synchronized into several aspects. The first aspect is introduction. The second aspect is piezoelectric energy harvesting. Following second, the third one is materials and methodology. Fourth one is discussion. Fifth is advantages and limitations of piezoelectric energy harvesting. And last but not the least, the applications, the potential applications of our imposed project. We first need to learn what is energy harvesting, and following that we will be learning what are the energy harvesting techniques. So energy harvesting is the process of capturing and converting energy from ambient sources such as light, heat, motion or vibration into usable energy that can power small electronic devices. I repeat, it's energy transferred from ambient sources such as light, heat and motion or vibration into useful electrical energy which can be later converted to run electrical devices. So from here we learn that what is vibrational energy. Vibrational energy is that energy which is converted into electrical energy through the use of energy harvesting devices such as piezoelectric materials. Piezoelectric materials, for example, can generate an electric charge which subjected to mechanical stress such as vibrations. We also should know that miniaturization of electronic devices has led to the development of small, portable and often wearable devices that need to be empowered by lightweight and compact power sources. The piezoelectric harvesting can be used in variety of applications including powering low power electronics, wireless sensors and even large-scale power generation systems. It does not require an external power source to operate. The third is it can be used in harsh environments, which is a very good application for being a merit in piezoelectric energy harvesting. And the last, so I also should reckon what are the materials and methodology of it. The first thing is piezoelectric materials converts ambient mechanical energy into electrical energy. The second methodology is electrodynamic shaker creates mechanical energy for vibration. Following that, piezoelectric ceramic plates attached to the shaker converts vibration to electrical energy. Following that, two generator setups were tested to two different configurations and frequency ranges, and last but not the least, voltage outputs were measured using a Puma vibration. We use a Puma vibration controller and analysis system. So let me sum up. The equipments were prototype generator, piezoelectric material, auxiliary equipment, Puma vibrator controller and analysis system. Are the mechanism of the energy conversion. The first mechanism that I should propose is piezoelectric material transforms mechanical energy into electrical energy. This is the mother concept of the whole piezoelectric conversion. Number two, ceramic piezoelectric plates converts vibration energy into electrical energy. Relative change in mechanical stress and strain deformation is used to produce electricity. Fourth is active materials in conversion mechanism produce electricity, resulting electrical energy is stored for future use. What are the roles of thermodynamic shaker? The first role is it creates mechanical energy to induce vibration in the piezoelectric material. Number two is it generates vibration along with the attached piezoelectric ceramic plates. Number three is it starts the very process of converting mechanical energy into electrical energy. Number four is it provides the necessary energy source for piezoelectric conversion. And number fifth is it provides a critical component in the setup of piezoelectric generator. So I want to conclude myself here, and I want to welcome my next member to present on his topic or his aspects regarding our topic. So I therefore conclude myself here, and thank you everyone for bearing me and giving me the floor. Allah Hafiz.
Assalamu alaikum. I'm MD Imtiaz Hussain Akash. I'm going to present how it works. The energy harvester consists of piezoelectric material, typically a ceramic or polymer, that exhibits the piezoelectric effect. These materials have a crystalline structure with positive and negative charge separated within the crystal lattice. Mechanical vibration. The harvest is designed to be subjected to mechanical vibration or deformation. This can be achieved by attaching the harvester to a vibrating structure or by placing it in an environment with mechanical vibration such as a moving vehicle or a human body. When the harvester is subjected to mechanical vibration, it experiences deformation and stress. The mechanical energy is converted into strain within the piezoelectric material. The strain causes the positive and negative charge within the piezoelectric material to separate, resulting in the generation of an electric charge across the material. This charge is proportional to the applied stress of deformation. The electric charge generated by piezoelectric material is typically very small, so it needs to be amplified and conditioned before it can be used. Harvesting circuitry, including amplifiers, rectifiers, and capacitor, is used to convert the alternating current produced by the piezoelectric material into direct current and store it in a storage element such as battery or a supercapacitor. The stored electrical energy can then be used to power low power electronic device or recharge batteries. It's important to note that the efficiency of piezoelectric energy harvester depends on various factors such as the quality and characteristic of the piezoelectric material, the design of the harvester, the amplitude and frequency of the vibration, and the load connected to the harvesting circuitry. Piezoelectric energy harvest have a wide range of application, including wireless sensor, network wearable device, industrial monitoring system, and self-pre-owned electronics. Two different setups were used to examine the energy capture for low and high frequency variations, resulting in different voltage output. The discuss emphasize the need to carefully consider factors such as the selection of piezoelectric material, generator design, vibration characteristic, and independent application. Thank you for the floor.
My name is Rafin Kabir, and I'm gonna be talking about the discussion part of the piezoelectric generator. So basically, the piezoelectric material should have high piezoelectric coefficients, high dielectric constants and high mechanical quality factors, because we are looking to produce to get a high power output. There are various piezoelectric materials available, such as ceramic, polymers, and other composites. So we have to choose the materials based on our individual needs. So now let's talk a bit about the design of the generator, because the design of the generator will determine how much output it will produce, and we are looking to produce as much output as possible. So everything we have to take into consideration, such as the size, shape, as well as the position and size of the piezoelectric material, because all of these factors will affect the output generated. Moreover, the generator should be designed in such a way such that the resonant frequency should be similar to that of the surroundings, because this will help produce in maximum output. Now let's talk about the vibration factor, since the vibration is the one which is producing energy. So we have to the vibration characteristic of the target structure, such as its frequency, amplitude, and also the shape, all play a role in how the energy is harvested. So the generator should be designed to match the vibration characteristics of the target structure to achieve maximum power output. Generator's natural frequency should be tuned in such a way such that it is similar to that of the ambient frequency, because we have to produce resonance frequency, and this will increase the coupling effect between the two. Now lastly, let's talk about the intended application of the generator. So basically, what kind of how big or small our generator will be, or how much low efficient or high efficient our generator will be, these factors depend on what our requirement is, the intended application, as we say. So for instance, if we want to power a low power mode wireless sensor, then our generator can be lightweight and small, so we have to design it that way. Thank you.
Thank you for passing me the presentation. I'll talk about the advantages of piezoelectric energy harvesting. There are so many advantages of piezoelectric energy harvesting, like high efficiency. Piezoelectric generator can convert the mechanical energy into electrical energy with a high efficiency. The efficiency can reach up to 80 to 90%. Another advantage of piezoelectric energy harvesting is like small size. Piezoelectric materials are extremely small. This makes them ideal for use in small electronics. Now moving on, the another advantage of piezoelectric materials are like they are extremely durable. They can tolerate high humidity, temperature, and pressure, etc. They also have a long lifespan. The last one, the piezoelectric materials are relatively cost effective. This makes the piezoelectric energy harvesting a cost effective technology for power generation.
Hello, Assalamu alaikum. My name is Tanjila Jaman. I'm gonna talk about here limitation. Narrow operating bandwidth. Piezoelectric harvesters are sensitive to the frequency of the mechanical vibration they are designed to capture. This means that they are only affected in a limited range of vibration frequencies and may not able to capture the energy from the vibration outside this range. Structural compatibility. In order to capture energy effectively, piezoelectric harvesters must be attached to a structure that is compatible with the mechanical and electrical properties of the material. Here we also see the sensitive. It is sensitive to temperature, and it has the design of piezoelectric energy harvesting system in a complex design. Moving to my next slide. Potential applications. Self-power sensor Piezoelectric energy harvesting is a popular choice for powering self-sustaining sensor used in structural health monitoring, vibration monitoring, and industrial automation applications. Automotive industry, piezoelectric energy harvesting can be used to harvest energy from the vibration of engine, suspensions, and tires to power onboard electronic or recharge the vehicle battery. Its potential application also seen in wireless sensor networks and aerospace industry. In aerospace industry, piezoelectric energy harvesting can be used and deformation of aircraft structures such as wings, fuselage, and landing gear. Moving to the next slide. Potential application use in wireless sensor node, MEMS, and electronic gadgets. Miniaturization. In miniaturization, piezoelectric energy harvester can be seen, which plays an important role for making this type of sensor nodes, electronic gadgets, making in miniaturization. Reliable. Piezoelectric energy harvesters have high reliability since they are not affected by the temperature change and can generate power even in low light or low temperature condition. In potential application of piezoelectric energy harvester, long lifespan can be seen, and it is also cost effective as powering wireless sensor nodes means an electronic gadget. It doesn't require battery replacement. Thank you. That's all from my side. Now my groupmate will continue.
Assalamu alaikum sir, this is Mohammad Aburwet Rokon. So in this part of the presentation I will try to explain the potential application of the project that we have worked on in the sector of wireless sensor nodes, MEMS and electronic gadgets. So as piezoelectronic materials can be very small and thin, it is suitable for use in MEMS devices, which refers to microelectronic mechanical system devices, and we can use it in other electronic gadgets. So it is also reliable as it doesn't get affected by temperature changes and can generate power even in low light or low temperature conditions. It also has a long lifespan as it requires minimal maintenance and can be designed to withstand harsh environmental conditions. So it also is cost effective as the solution for powering wireless sensor nodes, MEMS and electronic gadgets, since it doesn't require a battery replacement. So we have come to the conclusion part where I will try to end our presentation here. So far in our presentation we tried to discuss or demonstrate the use of piezoelectronic materials to convert vibrational energy into electrical energy that can be stored and used to power small electronic devices by using ceramic. The presentation or the report that we have submitted, it also discusses the factors that affect the efficiency of energy conversion, including the size and form of generator, the frequency and amplitude of the vibration, and the characteristics of the piezoelectronic material. So the presentation concludes that, or the report concludes that the energy harvesting with piezoelectronic materials is a promising field of research for creating self-powered microelectronic devices. So that was all from our presentation. So thank you, sir.